Safety at Delimara 4 is mandatory. The equipment at Delimara 4 is advanced and operates at high power and complexity. These systems involve forces and energies that are hazardous if not controlled. The plant supplies electricity to thousands of homes. The pressures, temperatures, and voltages require strict safety protocols. Shortcuts and complacency are not tolerated. Safety rules ensure all personnel return home safely after each shift. These rules must be followed at all times. Hazards at Delimara 4 are specific to power generation. Risks include more than minor injuries. System dangers are inherent and require specialized controls. High-pressure steam can escape if a valve is operated incorrectly. It is often invisible and can cause severe burns. High-voltage electricity is not detectable by sight or smell. Contact is often fatal. Flammable natural gas presents fire and explosion risks if not managed. These risks are present throughout the facility. Due to these hazards, safety procedures must be formal and strictly observed. A written set of safety rules governs all operations. Specific terminology in these rules is intentional. "You shall" indicates a mandatory action with no exceptions. "Practicable" or "reasonably practicable" allow for different methods to achieve safety, but do not lower the standard. Practicable means if a safety measure is technically possible, it must be implemented. Reasonably practicable involves assessing risk versus resources, but always prioritizes safety. Understanding this terminology is required for compliance. Distinguish between system dangers and general workplace hazards. General hazards include wet floors, poor lighting, or cluttered walkways. Procedures for these hazards differ from those for system dangers. System dangers include high voltage and high pressure steam. These require specialized procedures. Managing system dangers requires formal, methodical safety procedures as outlined in protocols.
So, how do we tackle these invisible giants? We do it through a core principle called safety from the system. This isn't just a catchy phrase, it's the bedrock of our entire safety philosophy. It means that before anyone even thinks about putting a spanner on a piece of equipment, we must first make that equipment demonstrably safe. We don't just hope it's safe, we prove it. The goal is to create a secure bubble around the work area, completely cut off from any and all sources of dangerous energy. This means we don't rely on a person's constant vigilance alone. Instead, we physically manipulate the system to remove the danger at its source, making it impossible for the equipment to become live or pressurized while someone is working on it. Let's use a simple example. Imagine you need to work on a large electric motor. Safety from the system doesn't mean just flipping a switch and putting a sign on it. It means going to the switch gear that feeds the motor and physically racking out the circuit breaker, creating a visible air gap in the circuit. Then, we lock that breaker in the off position with a unique padlock that only an authorized person has the key for. This prevents anyone from accidentally re-energizing the circuit. This process of isolation is the first critical step. We are physically disconnecting the motor from its power source in a way that is secure, visible, and under strict control. It's about creating a physical barrier, not just a procedural one. But what if there's stored energy? A disconnected cable can still hold a dangerous electrical charge, much like a camera flash capacitor. That's where the next step comes in. Earthing. After isolating the motor, we connect the electrical conductors to the ground using special earthing equipment. This ensures that any residual charge is safely dissipated, and that the circuit cannot become live if it's accidentally re-energized from another source. Similarly, if we were working on a pipe that contained high-pressure steam, isolation would mean closing valves on either side of the work area, but we'd also have to perform venting, opening a drain valve between the closed valves to safely release any trapped pressure. Only when the pressure gauge reads 0 is it safe to proceed. This is the essence of safety from the system. A deliberate, multi-step process to eliminate every potential source of harm. For high-voltage systems, it's about isolation and earthing. For pressure systems, it's about isolation and venting. For systems with mechanical moving parts, it's about isolation and immobilization. In every case, we are not just switching something off. We are creating a series of physical locks and barriers that make the system inert. This methodical process ensures that the work area is truly dead, depressurized, and de-energized,
allowing our teams to perform their tasks without the threat of the system unexpectedly coming back to life. It's about engineering safety into the job before it even begins.
To ensure safety from the system is applied consistently and correctly every single time, we follow a strict 5-stage process for any work on plant equipment. Think of these as the 5 commandments of safe work. They are non-negotiable. The first stage is identification. This sounds simple, but it's vital. The authorized person responsible for the job must go to the work site with the person in charge of the work and unequivocally identify the exact piece of equipment. Pointing from a distance isn't good enough. They will physically touch it, check its identification label, and confirm it against plant diagrams. This prevents a catastrophic mix-up where the wrong pump or valve is worked on, leaving the intended one still live and dangerous. Once the plant is correctly identified, the second stage is isolation. The authorized person goes to the relevant switchgear or valve stations and disconnects the equipment from all sources of energy. As we've discussed, this means racking out circuit breakers for electrical systems or closing and locking specific valves for mechanical systems. Every isolation point is secured with a safety padlock, to which only the authorized person has the key. A caution notice is then attached at these isolation points, warning others not to interfere with them. This creates a secure boundary that cannot be breached accidentally. It's a deliberate and documented action that forms the first layer of physical protection. The third stage is to lock off and post notices. After an isolation is performed, it must be secured. The authorized person applies a personal safety lock to the isolating device, the switch, the valve handle, and so on, to prevent it from being operated. A caution, do not operate notice is attached directly to the lock. Then, a main notice, the safety document, is posted at the point of work itself. This document clearly states what is being worked on and what safety measures are in place. This combination of locks and notices provides both a physical barrier and a clear visual warning system, ensuring everyone in the vicinity understands that the equipment is under a formal safety procedure and must not be touched. The fourth, and arguably most critical stage, is to prove dead or devoid of hazard. This is our moment of truth. For an electrical system, even after isolation, the authorized person must use a tested and approved voltage indicator to physically test the conductors and prove there is zero voltage present. For a pressure system, they must check a calibrated pressure gauge to confirm it reads zero. This isn't about trusting the isolation, it's about verifying it. It's the final proof that the system is inert before any work begins. For electrical systems, this is immediately followed by earthing, where the conductors are connected to the main earthing system, providing a final fail-safe layer of protection. Only after these 5 stages are complete is the equipment considered safe to work on. This robust safety system doesn't run itself. It relies on a team of trained and authorized individuals, each with a specific and crucial role. At the top of the operational chain is the control person, usually the shift manager in the central control room. They have the ultimate overview of the entire plant and are responsible for authorizing the release of any equipment for work. Below them is the senior authorized person, an experienced engineer who has been assessed and authorized to be responsible for the safety of a major part of the system. They are the ones who can issue and cancel the key safety documents. The authorized person works under the SAP and is authorized to carry out the practical steps of isolation and earthing and directly supervise the work. Working under the direction of the AP, we have the competent person. This is the skilled technician or engineer, the person with the spanners, who is carrying out the actual maintenance or repair job. They are deemed competent because they have the technical knowledge and skill to do the job itself, but they rely on the AP to provide them with a safe system of work. Finally, you might be classified as a selected person. This is someone, like a new trainee or a contractor, who isn't authorized or competent in our systems, but needs to be in a work area. They must be escorted and supervised by an authorized or competent person at all times. Understanding your role and its limitations is fundamental to your own safety and the safety of those around you. This whole process is governed by formal safety documents. The most important of these is the permit to work.
This is a formal written document issued by an SAP that details the exact piece of equipment, the work to be done, the isolations that have been applied, and the hazards that have been controlled. It is, in effect, a signed contract stating that the system has been made safe. The competent person must read, understand, and sign this document to accept responsibility for the work area. Another key document is the sanction for test, which is used when equipment needs to be temporarily re-energized for testing purposes under strictly controlled conditions. These documents aren't just paperwork. They are the legal and procedural record that safety has been managed correctly from start to finish. In conclusion, everything we've discussed today, the powerful machinery, the system dangers, the 5 stages of safe work, and the specific roles we all play, is interconnected. Mastering safety at Delimara 4 isn't about memorizing a list of rules. It's about understanding why those rules exist. It's about respecting the power we work with and appreciating the robust system we have built to control it. As a new operator, your most important job is to learn this system, understand your place within it, and never ever be afraid to stop and ask questions if you are unsure about anything. Your diligence and your commitment to these principles are what keep you, your colleagues, and the entire plant safe. Welcome to the team. Let's get to work, safely.